Hello, we are Pamela, Mariana, Memo, and Monse, and we are going to talk about rational functions, how to solve them, and we're going to give you some examples of them, how they are solved, how they look in a graph, etc.
To solve a rational function, you have to factorize both equations. So to factorize them, you have to look at for two numbers that multiply by each other give you -6 in the first equation and -2 in the second equation. And those numbers, the addition of both of them, they have to give you, in this case on the first equation, -1, and in the second, -1 too. So remember, you have a 1 here, because when you have just the x, it means that you have the coefficient of 1. So, but we don't write the 1. So let's start. I have these two multiplications, and in both cases they give you -6. So let's make the addition to know which is the result that is going to be on the function. So if you make -3 -2 the addition, it will give you -5. So that's not the correct answer, because we are looking for -1. And in the second case, 3 plus -2, it will give you -1. So that's the correct answer for the first equation. And for the second equation, I have the other two examples. So let's make the additions. 2 plus -1, it gives you 1. And -2 plus 1, it's -1. So this is the answer for the factorized function.
Find the vertical and horizontal asymptotes and the x and y intercepts. First, we will find the vertical asymptote. For the vertical asymptote, we have to equal to 0 the values of x in the factorized function. That means that we will equal x minus 2 and x plus 1 to 0. As you can see, I already did it, and the result of this will give us the vertical asymptotes, that in this case will be x equals 2 and x equals -1. So asymptote, we have to consider some rules. These are: if the numerator is greater than the denominator in its exponent, there will be no horizontal asymptote. If the numerator is equal to the denominator in its exponent, a division will be made. If the denominator is greater than the numerator in its exponent, the asymptote will be 0. In the original function, we can see that the exponents are equal. They are squared both up and down, and following the rules already mentioned, we can see that we will have to make a division. In this case, we will divide 1 over 1, and the result clearly will be 1. I will write it, and it will be y equals 1. This will be our horizontal asymptote. Now we will continue with the intersections of the function. To find the intersection of x, we will equal to 0 all the binomials of the numerator in the factorized function. That means that we will equal x minus 3 and x plus 2. The results are going to be x equals 3 and x equals -2. These are our x-intercepts. Finally, we will obtain the value of the intersection of y. For this we will substitute the x for 0 in the factorized function. Then we will cancel the zeros and we will multiply the remaining values, and this will give us the result of minus 6 over minus 2. And according to the law of the signs, we will change the negative for positive and divide the result. This will be 3.
Now that we have our intercepts and our asymptotes, we can make our graph. We used an online graphicator to corroborate our points, and we can see that they match. The y-intercept is in 0,3, is this point. The x-intercepts, we have two, one in 3,0, this point, and the other in minus 2,0, this point. And for the vertical asymptotes, we have two, one in x equals 2. So we use lines to corroborate. Another one in minus 1. We also have an horizontal asymptote in y equals 1. And now that we saw that our graphic was correct, we can get the domain and the range. For the domain and the range, we need to analyze the graph to see where does it start and where does it end. For the domain, we use the x-axis, and in this case, it doesn't have a certain point to start, neither to end. So we can infer that it continues. To write this, we need to put a parenthesis, minus infinite, comma, our first vertical asymptote that we can touch, so it's minus 1. We make a union from our first vertical asymptote to the second. And we need another union for this part of the graph, so it would be 2, infinite. And we do the same thing with the range, just that in this case we analyze the y-axis. So we put a parenthesis, minus infinite, we mark our horizontal asymptote, and we also need a union to mark this part of the graph, so it will be 1, infinite. And that would be everything for the domain and the range.
As we can see here, as x reaches infinite or minus infinite, y gets closer to y, but it never touches it. This is the function of the asymptote. It's a line that can never be touched. So even if we get to the infinite, the line will never be touched. It's a point that cannot exist in the space of the graph, and this is the NP of itself.